let me read the first question. The question is like this. A current passing through a circular coil of two turns produces a magnetic field at its center. The coil is removed as to have four turns and the same current is passed through it. What will be the magnetic field at its center now? Let me repeat the question once again and I will try to understand the question for you. So initially, solving any problems, we should understand the concept. And we should see some resemblance of concept that we have discussed in our theory class, so that you can easily find a solution to any kind of a problem that you face. So question is like this. There is a current which is passing through a circular coil of turns of two turns. So two turns of the coil is there, and which produces a magnetic field at its center. That produces magnetic field at its center. There is a one coil of two turns which produces a magnetic field at its center. The coil is rewound. Again, it is rewound at the same coil. I mean, the length of the coil will be same in the both conditions. In the first condition, there were only two turns. Now it is rewounded. Again, number of turns being changed. So as to have four turns. Now we are making the same length of coil as a four turns, and same current is passing through it. Then what will be the magnetic field at its center? Then what will be the change in the magnetic field at the center of the coil when the same coil made to four turns? So this is the question. Okay, let's start. So in order to solve this, we have to take one circular coil. We can take a coil like this. Okay. Then if you consider one coil, then what you have to do is you have to find the magnetic field at the center. So this concept we have discussed in our theory class. It can be, you have the resemblance of circular current carrying conductor. Same concept of we have discussed. And in that expression, we got the equation for magnetic field, and that was B is equal to mu naught I r square divided by 2 into x square plus r square to the power 3 by 2. This is the equation we got there. And here what they asked is, they asked to find out the magnetic field at the center. That is why we should put x is equal to 0 here. If you put x is equal to 0 in this equation, then you will get mu naught I by 2r. This is the equation to find magnetic field at the center. So we have two coils. Okay, this is the equation we have to use. And to do this, we have to follow this procedure. See, let L is the length of the wire. Okay. If the number of turns is 2, for n equal to 2, how to write the length? Can we write the circumference? Yes, we can write. 2 circumference is 2 pi r. Okay, let's say r is the radius of the first one when it has a 2 turns. Okay, this is the circumference of the one coil. So I am writing here because n is a variable here. For the first coil, it has only 2 turns. For the second coil, it has a 4 turns. That is why I am introducing the n here. n into 2 pi r1. For the first coil, n is equal to 2. That is why n is equal to 2 here for the first coil, or n is equal to 2, right? That is why 4 pi r1. Similarly, for n equal to 4, For n equal to 4, what you can write is n is equal to, again, n into 2 pi r2. Now the radius will change because we made the 4 times in the same coil with the help of same coil. So n into 2 pi r2, n is 4, so 4 to the 8 pi r2. And these are the lengths of the wire which is the same. That is why what you can write is L equal to L. That we can write, right? So I'm directly writing this one as 4 pi r1 is equal to 8 pi r2. So 4 ones are 4 twos. So that is why r1 by r2. Take the r2 here. So you left with the 2 on the r-axis. So r1 by r2 is equal to 2. So this is what we need while solving this. That is why we what we have solved, and we followed this procedure, and finally we got one result here. So which gives the relation between r and r2, because r1 is equal to, take the r2 here, 2 times r1. R1 is equal to 2 times r2. That you can do. Then let's find for n equal to 2, let's find the b. That is the b1. b1 is equal to mu naught times, what is the I? Yeah. For n number of terms are there, that is why n into I we should write. Should write n into I, n1, or n you can write n into current is I itself. Number of terms will change there. 2 into, for the first one, what you wrote is the R1. Radius of the first one is R1, right? So R1 we have taken, R1 we have taken. So let's substitute the value here. Let's substitute it here. So mu naught means 4 pi into 10 to the power minus 7. N means it is 2 into current. Current is the same current which you know, which is flowing in both the loops. 2 into R1. So here, so what you get is no need to substitute the value for this mu naught. It will cancel later, that is why mu naught into this much, that is why 2 cancels. So remaining is mu naught divided by r1. Similarly, for the same procedure, you have to follow the same procedure. For n equal to 4, b2 equal to mu naught times n into I divided by 2r2. So substitute here, mu naught, let it be mu naught itself, n is equal to 4 into I divided by 2 into r2. 2 into r2. Then this is 4. So then 2 other 2 2s are. So 2 mu naught I by 2 mu naught I by r. This is the second expression. This is 1. This is 2. So what we want is, we want to find the magnetic field when the same length of the wire is made to 4 times, made with the 4 times. So that in order to get the value of B2, what you have to do is 2 divided by 1. You have to divide the second equation by first equation. So B2 by B1, B2 by B1, B2 is equal to 2 mu naught I divided by R2, and divided means it should be inverse, then we should write the value R1 divided by mu naught I. So mu naught I cancels. R1 divided by R2 means it is equal to, we have written already R1 by R2 is equal to 2. So 2 into 2, that is equal to 4. So B2 is equal to 4 into V1. So this is the value for magnetic field of the same length of the coil is made to 4 times. So this is the answer for the first question. So now we are moving to the second question. Let me read the question. Two circular coins are placed coaxially with their centers 0.4 meter apart. The first coil is of radius 0.1 meter and has 10 turns, while the second coil is of radius 0.2 meter and has 20 turns. The current in the first coil is 0.5 amps and that in the second coil is 1 amp. Find the resultant magnitude of magnetic field at a point midway between the coils on the common axis when the currents are in the same direction and second one is in the opposite direction. So this is the question. So to get the clear picture of this question, we have to draw the figures. So let me try to understand the question in this way by drawing the figures. So there are two circular coils are placed coaxially. They are placed along the same axis. Coaxial means they are placed along the same axis. So let me take two coils. This is the one coil, and there are two coils. Imagine these are the two coils, okay, they are placed along the same axis and their centers 0.4 meter apart. Center of these two coils, let me draw the center and drawing a perpendicular line to the center of these coils. From the center of this one coil to the center of another coil, there is a distance 0.4 meter. Distance between them is 0.4 meter. First coil is of radius 0.1 meter. This coil has a radius 0.1 meter. R1, let me write R1 0.1 meter. And has 10 turns. That has 10 number of turns are there. While the second is of radius 0.2 meter. This has a radius 0.2 meter and has 20 turns. So let me write N2 is equal to 20. The current in the first coil is 0.5 amp. Current going through this is I1 is 0.5 amps. And that in the second coil is through this coil, current flowing through it is 1 amp, that is I2 is 1 amp. Find the resultant resultant magnetic field at a point midway between the two coils along the common axis. Along the common axis, in the midway between these two coils, what is the midway? What is the distance from center of one coil to another? That is 0.4. So midway between them, it will be 0.2 from each coil. Let us say this is the midpoint P. From this, so from one coil, the P is at a distance of 0.2 meter, and from the second coil also it is at 0.2 meter. So 0.2 is the midpoint from both the coils. Yes. So our intention, you have to find out the net magnetic field when current is flowing in the same direction. Let's say the current is flowing in the same direction. Then what will be the magnetic field? And second condition is if the current is flowing in opposite direction. Yes. So we should have one general knowledge that when currents are flowing in the same direction, then the direction of magnetic field will also be same. When the currents are moving in the opposite direction, then the direction of magnetic field will also be opposite. That is why when you are finding the total magnetic field, then if the currents are not going in the same direction, then we have to add the magnetic field since they are in the same direction. When the currents are in the opposite direction, then the net magnetic field should be subtract from one value to the another, because the direction of magnetic field will be opposite in such case. So this is a knowledge we should have while we discussing or solving any kind of problem. Yes. Now, for our intention is we have to find out the magnetic field along the axis. So similar kind of concept we have discussed in our previous chapters. That is, which is looks like a current carrying loop. And the concept of current carrying loop we have discussed in our class, and we have got an equation for the magnetic field along the axis of an current carrying loop. And the equation was V is equal to mu naught by 2 I r square into divided by x square plus r square to the power 3 by 2. So this was the equation. So we can apply this equation here for both the points, because we are finding the magnetic field at the P because of both the points, and the point is along the axis of the two points. That is why we can take this formula. And this formula was derived only from one coil. Here there are number of coils are there. On the first coil there are 10 numbers of turns are there. In the second coil there are 20 numbers of turns are there. So then there is a change in this equation. V is we have to multiply n here. That's all. Okay, I is the current flow of single coil. Then what is the current to n number of coils? That can be written like this: n into I into r square. That is the modification you have to do here. So let's do it for number of turns. For n1 equal to 10, then V1, let me write V1 mu naught by 2 into n1 into I1 into R1 square. We have written R1 here. R2 divided by x square. What is the distance? Yeah, x1 is equal to 0.2. x2 is also equal to 0.2 meter. We know here 0.2 b. That is the distance from B to the center of the coil. So x square plus r square to the power 3 by 2. Yeah, now we can do. So let's substitute the value for mu naught by 2. Mu naught by 2 means we already know the value of mu naught is equal to mu naught by 4 is equal to 10 to the power minus 7, or mu naught is equal to 4 by 10 to the power minus 7. Here already we have mu naught by 2. That is why in place of mu naught by 2 I can write 2 pi into 10 to the power minus 7. Which means that if you take the 2 here, that becomes mu naught by 4 is equal to 10 to the power minus 7. Sorry, mu naught by 4 pi is equal to 10 to the power minus 7, which is not similar. Okay, I have done some arrangements, and instead of mu naught by 2, I have written 2 pi 10 to the power minus 7, which is the correct. And into n1 is how much? 10 into current, I1 is 0.5, 0.5 into R1 square. Where is it? R1 0.1 whole square divided by x square plus I have written already x square is equal to 0.2 square plus r square is equal to 0.1 whole square to the whole power 3 by 2. Now what we have to do is, here we have to take the square of 0.2, then we have to take the square of 0.1. After squaring, we have to add. After adding, we should take here this 3 divided by 2 is, we can write this as 1 by 2 into 3. There one and the same, either writing 3 by 2 or 1 by 2 into 3, which is one and the same. So after squaring and after adding, we should take the square root of it. 1 by 2 is right, that's why we can take the square root of it. After taking the square root, we have cube, then we have to multiply thrice. 3 times you have to multiply the value so that you will get the answer of this the value of this denominator. So once you do that, and also you have to calculate this. After calculating, you will get, I have calculated this, that is why I am directly writing the value here. 28.8 into, 28.1 into 10 to the power minus 7 Tesla. Okay, this is the value for B1. Similarly, for N2 is equal to 20, B2 is equal to mu naught by 2 N2 I2 into R2 square. For the second, while I am writing x square plus R square, x square plus R1 here should I have to write, and here I should write R2 square to the power 3 by 2. Let's substitute the value. Mu naught by 2 is 2.2 10 to the power minus 7 into number of turns is N2 is equal to 20 into I2 is equal to 1 into R2 is 0.2 whole square divided by 0.2 whole square, x square is 0.2 whole square, plus R2 square is again it is 0.2 square to the power whole power 3 by 2. I told you how to calculate the denominator. Again I am telling you, take the square root of this, take the square root of this, add it. After adding, take the square root, then multiply thrice. Okay, so that you will get the denominator value. So I have calculated this. So I got 222 into, which I got is 222.1 into 10 to the power minus 7 Tesla. So this is the value I got for B. Now we have the value for B1 and B2 at the point P. Okay. Now what we have to do is first condition. That is what we have to find out here. First condition, when the currents are in the same direction, then I told you to find the magnetic field, we have to add the two magnetic fields. B2 plus B1. So B2 plus B1, B2 is equal to 222.1 into 10 to the power minus 7 plus B1 is equal to B1 is equal to B1 is equal to 28.1 into 10 to the power minus 7. If you add this, you will get 222, 28, again 250.2 into 10 to the power minus 7. So this is what answer for the first one. Similarly, for the second, so the current are in opposite directions. Then what I told you, to find the magnetic field, we should subtract the magnitude of one with another. So B is equal to, we are writing the higher value to the beginning, otherwise it will get a negative sign. B2 minus B1 is equal to 222.1 into 10 to the power minus 11 minus 28.1 into 10 to the power minus 7. So if you subtract this, you will get 194 into 10 to the power 194 into 10 to the power minus 7. So this is the answer for this question.